Welcome to solving for a series circuit. If you know the applied voltage and all the individual resistors in the series circuit, there's 4 steps to solve. That's what I'll show you today. This is important because before you go into the lab and build it and measure it, you need to know what you expect to get versus what you might get if you have a problem in the circuit, so you can troubleshoot it and fix it. So let's go through the 4 steps for solving for a series circuit. The first step is to get the resistance total. In series, the resistance total is the sum of the individual resistors. In this case, R1 plus R2 plus R3 will give us our resistance total. Our resistance total, here's our formula. Here's the numbers we put in. 1K plus 2K plus 3K is equal to 6K ohms, or 6,000 ohms of resistance. And once we have this here, let's label it on our schematic, 6K ohms. By labeling our schematic, we can now see that we know 2 things here. We know the voltage total and the resistance total. Knowing these 2 things, we can use Ohm's law to get the current total. Ohm's law says the current total is equal to our voltage total divided by resistance total. That's 12 volts divided by 6K ohms. And that gives us 2 milliamps of current flowing in the circuit. Current's constant in a series circuit. So if we have 2 milliamps here, and let's label our schematic. If we have 2 milliamps here, then our third step is simply to apply this current to all of our series components. So if there's 2 milliamps here, it's like water in a pipe. We have 2 milliamps here, and 2 milliamps across R2, and 2 milliamps across R1. Our fourth step is to use Ohm's law to solve for the individual voltages of the resistor values. If we start with R1, that would be the current of R1 times the value of R1. So the voltage of R1 is equal to current times resistance. That's equal to 2 milliamps times 1 k ohm. And if we do the math, we find out that's 2 volts. We come up here and we label our schematic, 2 volts. We know all 3 things here. So we move on to R2. We know our resistance and our current. We multiply the current of R2 times the value of R2 is 2 milliamps times 2 k ohms of resistance. That's going to give us 4 volts. So we label 4 volts across R2. And one more step. To get our voltage across R3, it's the current of R3 times the value of R3. That's 2 milliamps times 3 k ohms is going to give us 6 volts. We label our schematic. We know 3 things, 3 things, 3 things, and 3 things. We're finished. For a quick check, let's add up our individual voltages and see if they add up to the total. 6 volts plus 4 volts is 10, plus 2 is 12 volts. We have 12 volts applied, 12 volts dropped. We must have done something right.